Okay, let's take a look at adding and subtracting polynomials. Addition, of course, is much easier and will be our friend. How do we add polynomials? To begin with, remember that polynomials are groups or more than one term in a string, in an expression. If you are going to add, we are going to try to combine like terms and rewrite in standard form. Recall, standard form means that the largest exponent, the term with the largest exponent, comes first. I have 15m to the third, 6m to the second, 2m to the third. I am looking for the same variable and the same exponent. I see that I have two terms that fit that category. I can add the coefficient 15 plus 2. I get 17m to the third plus 6m to the second. I have a degree of 3, a degree of 2. I have a lead coefficient of 17. I have two terms in my polynomial. Let's look at this one. Don't be frightened when you see all these numbers on the screen. Let's just take one line at a time. 0.9y to the fifth. Here's another one, y to the fifth. X to the fifth. Y to the fifth. The minute I see the y to the fifth, I've seen it 3 times. I like to underline each one that I feel is a like term so that I can then go back and go ahead and combine them. 0.9 minus, I have a negative 0.4. And then here, what's in front of that y that you can't see? The invisible 1. When I combine all that together, I get 1.5y to the fifth. I bring down my 0.5 x to the fifth. They both have a degree of 5, so you can leave them in whichever order you prefer. Let's take a look up here. 2x to the second y, 3x to the second y, negative 4x, positive 2y. I have x to the second y, x to the second y, just plain x, just plain y. I underline the two that are like terms. Combine the coefficients. I don't combine the variables. The variables just remain the same. 5x squared y, degree of 3. I have 3 terms. I have a lead coefficient of 5, which is right here, the coefficient of the first term, and I have degrees of 3. 2 plus the invisible 1 above the y. Add exponents within a term to calculate degrees. So if you need to put in those invisible ones, you need to do that. When you're combining like terms, you add coefficients, not exponents. All right, what happens if I have 2 polynomials and I'm adding them together? My first polynomial, 2x squared minus 1x. My second polynomial, 1x squared plus 3x minus 1. 2 options. Option 1, I can combine like terms because this is addition of 2 polynomials. All signs will stay the same. All I have to do is drop the parentheses and combine like terms. Easy enough to do. I have an x squared, an x squared. I have an x, I have an x. Notice that I've used different colors. I'm a big fan of colors when I do my notes and when I ask my students to do their notes. So use your colors so that you can see what you're doing. Combine the red terms. I get 3x squared. This is a negative 1 and a positive 3, makes a plus 2, positive 2, and my constant, negative 1. Option 2, I can do a vertical alignment where I start with the largest degree and I go down to the constant. So I can see that x squared was my largest degree. My first column will be x squared, and then I just go down, x to the 1, and then no x at all, which is called constant. I look at my polynomial, 2x squared. I put it in the x squared column. Negative 1x in the x column. Positive 1x squared, I put it in the x squared column. Positive 3x, I bring down and put it in the x column. And the constant, negative 1, is in the constant column. Now all I do is add up each column and combine them together. 3x squared plus 2x minus 1. Simple. Here's one that you can try. Now, of course, we all already know that I don't have my screen because I'm unable to get the correct tools here at home. But let's just cover this up for a minute. I have 5a to the third plus 3a squared minus 6a plus 12a squared plus 7a cubed minus 10a. Gosh, that went on for a long time. It's okay. It's addition. Just remove the parentheses and let's just start to put things in vertical alignments. My largest degree was a 3. So here it is, a to the third, a to the second, a constant. Simple. 5a to the third, 3a squared, negative 6a. Here's 12a squared. Oh, that's already there. It's okay. Put it right underneath it. 12a squared. 7a to the third, negative 10a. Now all I have to do is add the columns. 5 plus 7, 3 and 12, negative 6, negative 10, negative 17, or 16, sorry. Now it is also automatically in standard form. So you don't have to worry about rearranging the terms when you use the vertical column method. Subtraction. Subtraction is much more complicated if you make it complicated. I'm going to try to make it easier on us. Subtracting polynomials is the same as adding the inverse. I can take negative 2x to the third, or let's call this subtract. Subtract 2x to the third minus 3x plus 7. That is the same as saying addition, add the inverse of each term. So if I take the inverse of each term, I get negative 2x cubed, a positive 3x, and a negative 7. It becomes complicated. Not everybody wants to do all that. I have a suggestion. A to the fourth minus 2a is my first polynomial, minus 3a to the fourth minus 3a plus 1. What if you put an invisible 1 in here and you use the distributive property, which we have done many, many times? I get negative 1 times 3a to the fourth, negative 3a to the fourth. Negative 1 times negative 3, two negatives make a positive 3a. Negative 1 times a positive 1 makes a negative 1. I have now changed all the terms in the second polynomial to their inverse. But I can see why I did it. By using the distributive property, I can understand why I changed them to their inverse. Now I still have to use addition and combine like terms. A to the fourth, I have a positive 1, a negative 3, and I get a negative 2a to the fourth. I have a negative 2a and a positive 3a, gives me a positive 1a and a constant of 1. You'll have to make that decision for yourself if you want to just convert every term inside the parentheses to its inverse, or if you'd like to use the invisible 1 method and multiply each item in the second polynomial. Option 1, change subtraction to addition and add the inverse of every term inside. You learned this rule when you did rules of integers long ago in Unit 1. The problem here, do you see we have two signs next to each other? You can't have two signs, so you have to clean it up. You have to clean up the double signs. A positive and a negative makes a negative. And you have to combine like terms. So you're still going to combine like terms. Again, we find all of the terms that are the same, and we get 2x squared minus 3x. Or you do the multiplication with the invisible 1. You will still have to combine like terms. That's not going to go away, but you might find it easier. Plus, when we get to multiplication of polynomials, you'll have some experience because you're going to use multiplication a lot and you're going to use addition a lot. You can get away with never using subtraction if you just use the invisible 1. Option 2, here's my vertical tables. Now I've gone and cheated here because I know that some of my students get kind of lazy. So instead of rewriting everything, I just get rid of the net subtraction sign and I change everything to its inverse sign and bring it down. Pay no attention to that if it's confusing to you. My students already understand that I was just using the cheater's way of doing this. But you rewrite everything and you are able to continue to get your correct solutions. So whether I use the vertical or I use horizontal, combining like terms with option 2, either way, I still had to do all of this, but now I put it into vertical form and I went straight to 2x squared minus 3x and I have my solution. How about if you try some? So here I have 2 examples for you to try. I want you to go ahead. Here's one is addition. I want you to place your terms in the right vertical columns. This one is subtraction, so don't forget to work with the second polynomial. Make your vertical columns and give me a solution. I'll ask you to pause your video at this point because I'm going to go on to the solution. So pause. When you're done, you may begin again. Here we go. Here are the solutions. I hope yours looked just like this, and I hope you were able to get the right answers. And I'm hoping that you feel really confident about doing addition and subtraction with polynomials. Oh, didn't want you to see that answer. Here's one more for you to try. It's a little bit more complicated. Go ahead and pause. After you've turned the pause off and you have a solution, I hope it's this, 16d squared plus 1dx plus 9x. Good luck with addition and subtraction. It's not that hard if you don't panic. Addition is really easy, combining like terms, and subtraction can be made easy by just using the invisible 1 with the distributive property. See you when we get to multiplication and division.